Kepler's third law. Kepler's third law states that the square of the period of revolution of any planet, the square of the period of revolution of any planet around the Sun is directly proportional to the cube of its mean distance from the Sun. Again, I am repeating, the square of the period of revolution of any planet around the Sun is proportional, directly proportional to the cube of its mean distance from the Sun. Now, we will prove that this t square is proportional to r cube, time period around the Sun, square is proportional to cube of its distance from the Sun. Kepler's third law can be easily proved by assuming the orbit of the planet to be circular, with the Sun obviously at the center of the circle. The Sun's gravitational energy or gravitational force provides the necessary centripetal force for the planet to orbit the Sun. Formula of gravitational force: G mm by r square. Capital M, S is the mass of the Sun, and small m is the mass of the planet, and r is the distance from the Sun. So G m by r square is equal to mv square by r. That is the centripetal force. As the gravitational force from the Sun provides the necessary centripetal force for the planet to move in the orbit in a circular manner, therefore G mm by r square is exactly equal to mv square by r, where G is the gravitational constant, ms, as I told, is the mass of the Sun, small m is the mass of the planet, v is the velocity of the planet in its orbit, and r is the radius of the orbit, which means r is the distance of the planet from the Sun. So you can see that at both sides there is small m, so we can cancel the small m, and in the both sides denominator, on one side, on the left hand side there is r square, and right hand side there is r, so we can cancel one r from the left hand side, so it becomes gms by r equal to v square. Gms by r equal to v square. So we can make v the subject. So we know that v, the velocity, is equal to 2 pi r by t, distance by time. Total distance is the circumference of the orbit, 2 pi r, by the time period is the linear velocity of the planet. T is the time period of the planet. So we can substitute v in the equation and write it as 2 pi r by t. So it becomes gms by r equal to 2 pi r by t whole square. So now gms by r is actually 4 pi square r square by t square. So now we can make t square as the subject. T square will become 4 pi square into r cube by gms. Now you can see 4 is a constant, pi is a constant. Capital G is the universal gravitational constant, and the mass of the Sun cannot change, it is also a constant. So therefore 4 pi square by gms is a great constant into r cube. If we write the 4 pi square by gms as k, a constant, so it becomes t square is equal to kr cube, or in other words t square proportional to r cube. That means the square of the period of revolution of any planet around the Sun is directly proportional to the cube of the mean distance of the planet from the Sun. This is the proof of Kepler's third law. The constant k is same for all the planets in the solar system and has a value of 2.97 into 10 to the power minus 19 second square per meter cube. Now if we are considering the motion of moon around the earth, or the motion of other moons around other planets, then the value of this k will change, because the value of k depends on the mass of the parent object or the parent body around which the planet or the satellite or the moon is revolving. And if the orbit of the planet or moon is an ellipse, then R can be replaced by the semi-major axis of the ellipse. This was all about Kepler's third law. For general knowledge, you can know that Kepler published his third law many years after he published his first and the second law. His first and the second laws were published in a single book called Astronomy Nova, a German book, and later he published his third law, which was published on another book. If you found this video helpful, then you can subscribe my channel and like this video to get updated about these kinds of videos, space videos related to astronomy and physics. Thank you.